Saxon Algebra 1, Lesson 75. This is a good one. I really like it. It's about the equation of a line. What does that even mean? Let me show you. We have been graphing lines. We've been given things like this. And we've been told that that represents a line and we should graph it. We should choose values for x and then calculate the values for y, do three of them, and then graph them, and they should connect the dots, right? So we make a little chart that looks like this, right? And we write x here, and we write y here, and then we write this part in the middle. That's like our worksheet, right? And what we do then is we choose values for x that are simple, easy numbers, close to 0, right? We don't want to draw a massive graph. We just want to keep them all close to the middle. Because remember, our graph looks like this. And we can count out 1, 2, 3. I'm not going to put the numbers on yet. 1, 2, 3, 1, 2, 3, 4, right? We make our own graph paper. We know the very middle here is 0, 0. So we want to keep it close. So I'm going to choose for my first, there's no fractions here. Sometimes if there's fractions, you have to be really clever about choosing numbers so that you don't get fractions in your answer. But we don't have that problem. So I'm just going to choose 1. Then we plug 1 in for x here in our work area. 2 times 1 is 2. Minus 3 would be -1. Okay, so we're going to plot that point later. We're not going to do it just yet. Let's choose -1. That went so well. 2 times -1 minus 3, right? I'm copying this and just plugging this in for the x. This would be -2 minus 3. Oh, that's different. That's -5. Oh, that's getting to be kind of a big number. I don't want to go in that direction. Let's choose 0. 0 is always a nice choice. 0, 2 times 0 minus 3. 2 times 0 is 0. 0 minus 3 is -3. Okay, there are 3 pairs of points and we will graph them. We'll graph this point first. 1, -1. There it is. -1, -5. Oh, -1, -5. We have to go way down here. 1, 2, 3, 4, 5. And this is 0, -3. 0, -3. So that would be right there. Okay, so we have 3 points. They look like they line up. I'm going to use my super technical tool for drawing straight lines. Hey, it works. And this is the line that we get, right? We call it y equals 2x minus 3. That's the name of this line. And we've used it, we've graphed it using the point calculation method. Now, I don't know about you, but I find this whole chart thing kind of annoying. I would like a faster, easier way to do that if it's at all possible. And the answer is yes. If we look, I'm going to copy this again, y equals 2x minus 3. We'll see that this line, this equation of a line, ding, 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 fits a pattern. The pattern we call y equals mx plus b, all right? And we notice it's y by itself, some number multiplied by our x, plus or minus another number. We use this pattern to graph, and it's way easier. But we have to break the code first. What does this b mean? This b is what we call the y-intercept. Okay? It's the place where our line crosses the y-axis and we can also calculate it anytime by letting x equal 0. Okay? And I'll come back to this and talk more about it later. All right, so that's how we find this b number. Now what about this m number? M is what we call the slope. If m is a positive number, we calculate it as the rise over the run. The slope becomes like a little treasure map that takes us from the y-intercept to the next point. And it gives us 2 points to draw a line. I'll show you what I mean in just a minute. If the slope is negative, it behaves in a similar way, but this time instead of rising, we call it the sink over the run. Okay, so when we're using our treasure map, if we see that m is a positive number, then we know we'll go up and then to the right as we take our steps from the first number to the second. If it is a negative number, we know that we go down and across. And I want to show you a picture in the book, and I want you to burn it into your brain forever because it's really, really cool. I mean, I think it's really cool. If you have a positive slope and you imagine that there is a little person, namely you, in a car driving on the slope is going uphill. Okay? If you imagine yourself in a little car and you're driving on a negative slope, then you are going downhill. So when you're looking at slopes, you can easily determine if it's a positive slope, if m, that number, should be positive or negative. You'll know just by thinking of this little car lady. I think she has her hair in a bun. There's a picture in a different textbook, I think Algebra 2, where she has her hair in a sassy little ponytail, which I like even better because I imagine her ponytail flying in the breeze as she goes flying up these hills and down. But uphill is a positive slope, downhill is a negative slope. I will reference this and talk about, the little car is going downhill, so we know it's a negative slope. So keep that picture in your brain. All right, so uphill slopes are positive, downhill slopes are negative. When we graph, one other thing I want to say before we actually practice this, we do the y-intercept first, we plot that, then we use the slope as a treasure map to lead us from this point to the next point. 2 points are all we need to draw the line. Back here we were doing 3, no more, my friends, just 2. Okay, so let's flip the page, leave all our explanatory notes behind. I'm gonna write this much, and I'm gonna write that first we do the y-intercept, and then second we graph the slope. That's the order we do things in. So let's take our original equation that we graphed, do the old way, and let's graph it the new way. First, we do the slope. This is, B, rather, sorry. This is B, this is our y-intercept. We go to the y-intercept, or the y-axis rather, that's this one, right? This is x. We go to y, and we go to the point of -3. That's our starting point, okay? We always start with the y-axis, and it's super easy to find. It's gonna be on that line somewhere. We just go to this number on the y-axis. So this is -3, we can write that in. And again, I told you before that x equals 0. Yeah, x is at 0, isn't it? Right there. Okay, now we go to the slope. Now the slope always needs to be a fraction. I see no fraction, but I can always make one, right? So turn your slope into a fraction. This is a positive number, so I know that it's the rise over the run. The run always goes to the right. The rise goes up if it's a positive slope, it's a sink, and it goes down if it's a negative slope. So I go here to my starting point, and I'm gonna go up 2, and then 1 to the right. 1, 2, 1 to the right. I draw in my markers just as I need them. Now, I just use 2 points to draw my line. We have a higher degree of confidence with these lines because we're not really doing any calculations, are we? We're just pulling the numbers right out of the equation. This is our answer. Let's compare it to our other answer. Look. It's exactly the same, and our points are even the same, right? It was 0, -3, and then this is 1, -1. 0, -3, and then 1, -1. It just happened that we got the exact same points. Would you agree that graphing it this way, using the slope-intercept method, which I think should be called the intercept-slope method, because that's the order we use them in, it's way, way easier and faster. So we don't have to deal with those silly little charts. We're just going to have fun. All right, these first few problems are barely even problems. 75.1, find the y-intercept of the line whose equation is y minus 3x, oh wait, y equals 3x minus 5. Okay, the y-intercept is always this thing. So the y-intercept, I'm abbreviating, equals minus 5. That's the right answer. 75.2. Find the y-intercept of the line shown. Okay, the y-intercept is the place where the line crosses the y-axis. Here's the y-axis, going down like this. Here's our line crossing. John has been kind enough to even write the name of the point. So all we have to do is say that at that point, the y-intercept equals positive 5. Again, we didn't have to do a single thing. We just looked at it, and there it was. This is right. This is right. Okay, let's try the third one. The third one, we don't really even need to write anything down. It says, find the equation of the lines graphed in the accompanying figures. Well, we'll write it down. We'll write down our answer. All right, so there's like an A and a B. Okay, so the first thing we want to find out when we look at the picture and try to figure out what the line is we want to figure out where it crosses the y-axis, right there at positive 3. So we know that for this first one, it's going to be y equals something x plus b, our y-intercept, and the y-intercept we saw was positive 3. Now, we have to decide if this is a positive slope or a negative slope. That's our first dilemma. And we see, oh, it's going, the little lady's going down the hill, right? So, or us, however you'd like to embody that picture. It's going downhill. So we know it's going to be a negative slope. So we know it's going to be the sink over the run. So we count from one point to the next point. There are two really sharp, clear points, right? So we're going to go down 3 and then over 2. And it's a negative slope because we're going downhill. So it's minus 3 over 2 plus 3. So this is our answer. We can find the equation of a line just by looking at the picture. What the actual heck? We're so smart. Let's do the other one. Again, first we look for the y-axis and we find out where the line crosses. -2. So that is our b value. We can write y equals something x minus 2. Okay, now we need to find the slope. Now this slope we can see is a positive slope. It's going uphill. So it'll be the rise over the run. So we go from this point to say that point, right? We can pick any 2 points. We just choose what's easiest to calculate. And here the line is just meandering through our graph paper. Well, it looks pretty sharp there. We're looking for places where the line touches the corner. It goes up 1, 2, and over 1, 2, 3, 4. Aha, so that's a positive 2 over 4 slope. And I see, oh, we could reduce 2/4 to 1 over 2. Let's see if that works. What if we go up 1 and over 2? Oh yeah, it comes out right there at that point. So it's positive 1/2 is our slope. So I'm just gonna write 1/2 like that. And that is the right answer here. Okay, so we can just look at these pictures now and find the equations of our lines. We are powerful. We're gods and goddesses. Example 75.4. Turn the page. Graph. Y equals minus 3 over 5x, the woman's going down the hill in her car, plus 2. We intercept at positive 2. Okay, so we draw our graph. Again, keep it minimalist. Don't put a bunch of hashes and numbers on there unless you're sure you need them. Positive 2. Okay, I'll put that in. I'm not even going to write the number, but I could. This is 2, positive 2. Now this tells me I'm going downhill, so this is the sink over the run. The sink goes down. The run always goes to the right. The bottom number always goes to the right. Okay, so we go down 3, 1, 2, 3, and then over 5. I'm going to have to fill those in, aren't I? 1, 2, 3, 4, 5. Right, let's double check. We went down 3, 1, 2, 3, 1, 2, 3, 4, 5. Remember that when you're counting from one point to another, you count just like you do in the board game. A board game, you don't count the space you're on, and you just count each jump that you make, right? 1, 2, 3. 1, 2, 3, 4, 5. I had a student once, delightful, wonderful student, and we were going through this, and she kept counting wrong. She kept counting the number of spaces wrong when we were calculating the slope. And I said to her, do it just like you do in a board game, right? Where you don't count the space that you're on, you count your jumps, right? You go 1, 2, 3. And she looked at me with the look of pure astonishment on her face, and she said, that's how you do it? I never knew that. I thought you counted starting with the space you're on. So we had a good laugh over that, and she learned lessons about board games and slope. She realized she'd been cheating herself out of a jump every single time she played a board game. So don't count the space you're on, count the jumps. 1, 2, 3. 1, 2, 3, 4, 5. And there we have enough to draw our line. Again, remember, 2 is good enough because we're not having to calculate anything. Ooh, 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 that really didn't work out at all, did it? Let's try again. Better. But you get the idea. The name of this line is y equals minus 3/5 x plus 2. You know I'm normally not a fan of floating symbols in math equations, but floating the x is okay. You'll see what I mean as we go. All right, next one. Use the slope-intercept method to graph the equation x minus 2y equals 4. Well, holy crackers and hold the bus. In order to use our nifty new graphing method, the equation has to be in this shape. And as I wrote this down, this x minus 2y, ooh, no. So we have to do a little algebra to clean up this and get it into this shape before we can go any further. So I want the x to be on the right side. So I'm going to subtract the x from both sides. And then I get minus 2y equals minus x plus 4. And now I have to divide this minus 2 away because I need the y to be plain. All right, so now let's simplify. That's gone. Y equals, the 2 minuses cancel out. And what I'm going to do, it's x over 2, but I'm going to write it this way. I'm going to pull the numbers apart from the letters. So I have to put a 1 up here to hold the place in the numerator because this makes it easier to do my slope. I don't want to write it as x over 2. And then this simplifies to minus 2. Okay, remember that a fraction in this place is a pain in the neck. A fraction in this place is perfectly fine because it's just the treasure map. So it doesn't bother us at all to have a fraction over here. Let's graph now. We start at minus 2 on the y-axis, that's the x, and this is a positive slope, so it tells us to go up 1 and then over 2. Up 1 and over 2. there is our next point. Let's see if I can do any better with drawing my line this time. I think it was the angle I was working at with the pen, because that one was easy for me. Okay, so there's the line. We say the name of this line is y equals 1/2 x minus 2. Every single pair of points on this line, and that's all it is a series of connected points. Every single one we could plug the x in here and the y would come out to be the right number. That's what a line shows us. Pairs of points that will make this come true. Happy days, right? So equations of line are very cool. They are what we call functions. This is a function because it's a mapping of numbers for x that relate to numbers of y, right? If I say put 1 into this place, I will always get the same number for y. X equals, well, let's use -2 and 0, right? If I put in 0 here, I get -2 here every single time, every day of the week. If I come, I've been teaching this book for 20 years. Every single time I've done this problem, you put in a 0 here, you get a -2 over here. It never changes. That's what we mean by a function. It's a mapping or a pairing off of certain values that always belong together. All right, so we call this a linear function. And with that fascinating nugget of truth, I am going to end this lesson. Thank you. Goodbye.